Every day, you open websites like youtube.com, google.com, or netflix.com. You type a simple name into your browser, press enter, and the website appears within milliseconds. Behind that simple action, something important happens first. Your computer has to figure out where youtube.com actually lives on the internet. Computers don't understand names like youtube.com. Humans remember names because they are easy. Computers communicate using numbers, called IP addresses. So before your browser can connect, it needs to find the IP address behind that name. That process of finding the IP address is called a DNS lookup. In simple terms, DNS helps your computer answer one question: what IP address belongs to this domain name? Without this lookup, your browser would not know where to send the request. DNS stands for Domain Name System. It is the naming system of the internet. Humans use domain names because they are easy to remember. Computers use IP addresses because that is how they locate and communicate with machines. DNS connects these two worlds. You can think of DNS like a contact list for the internet. You know the name, and DNS helps find the address. Once the IP address is found, the browser can move to the next step. DNS connects names for humans with addresses for computers. A common beginner mistake is thinking DNS is one giant database somewhere. A centralized system would be a terrible design. If that one server went down, the internet would break. If every user asked the same server, it would be overloaded instantly. Instead, DNS is distributed. No single server needs to know everything. Different DNS servers work together. Each server helps point the resolver closer to the final answer. That is what makes DNS scalable, reliable, and fast enough for the modern internet. When you type youtube.com, your computer does not immediately ask the whole internet. First, it checks nearby memory. Your browser may already have the answer saved. Your operating system may also have the answer cached. If the IP address is found there, the lookup can finish almost instantly. But if it is not found, your computer asks a DNS resolver. The recursive resolver is the server that does the hard work for your computer. It is usually provided by your ISP, company network, or a public DNS provider. The resolver first checks its own cache. If it already knows the answer, it returns it immediately. But if it does not know, it starts searching through the DNS hierarchy. The resolver first asks a root DNS server. The root server usually does not know the exact IP address of youtube.com. Instead, it looks at the last part of the domain, .com. Then it tells the resolver, I do not know YouTube's IP address, but I know who handles .com domains. Go ask the .com TLD server. Now the resolver asks the .com TLD server. TLD means top-level domain. In youtube.com, the top-level domain is .com. The .com server manages directions for .com domains, but it still usually does not return the final IP address. Instead, it says, I know which authoritative DNS server is responsible for youtube.com. Go ask that server. Now the resolver reaches the authoritative DNS server. This server is different from the root and TLD servers. It is the source of truth for this domain. It knows the actual DNS records for youtube.com. So when the resolver asks for the IP address, this is the server that can finally return the answer. The authoritative server checks its DNS records. For example, it may find an A record. An A record maps a domain name to an IPv4 address. So the authoritative server returns the answer. youtube.com maps to this IP address. Now the resolver finally has the information it was looking for. Once the resolver receives the answer, it sends the IP address back to your computer. Your browser now knows that youtube.com maps to this IP address. At this point, the DNS lookup is complete. DNS has done its job. It did not download the website. It only answered one important question: what IP address belongs to this domain? Let's quickly recap the full DNS lookup. You type youtube.com into your browser. First, your browser and operating system check cache. If the answer is not found, your computer asks a recursive resolver. The resolver asks a root server. The root server points it to the .com TLD server. The TLD server points it to the authoritative DNS server for youtube.com. The authoritative server returns the IP address. Then the resolver sends that IP address back to your browser. And now the domain name has been resolved into an address. DNS does not only store one type of answer, it stores records. An A record points a domain to an IPv4 address, and quadruple A record points a domain to an IPv6 address. A CNAME record points one domain name to another domain name. An MX record tells email where to go. And a TXT record stores text, often used for verification or security. So DNS records are instructions that describe how a domain should work. In the real world, developers manage DNS records using DNS providers. This could be Cloudflare DNS, Amazon Route 53, DigitalOcean DNS, Google Cloud DNS, or the DNS tools provided by your domain registrar. This is how you point your domain to your server. A common example is an A record. Suppose your server has this IP address. You can create an A record that points myapp.com to that server IP. Now when users visit myapp.com, DNS can tell their browser which server address to use. This is how a domain becomes connected to a real application or website. Now there is one more important concept: TTL. TTL means time to live. It tells DNS systems how long they can keep a cached answer. For example, if a record has a TTL of 300 seconds, it can be cached for 5 minutes. After that, DNS systems should ask again for a fresh answer. DNS is not just a basic internet feature. It is important for real systems. Large companies use DNS to route users to nearby servers. They use DNS with CDNs to improve speed. They can also change DNS records during migrations or failures. So DNS helps with performance, reliability, scalability, and availability. It is one of the invisible systems that keeps the internet usable. DNS only resolves the domain name to an IP address. It does not download the actual website content. Once the IP address is found, the browser takes over to connect to the server and download the website. Remember, the process is, you type a domain name, DNS finds the IP address, and now the browser knows where to go to load the website.